Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at our study guide in preparation for Chapter 8, Test Number 2. This is going to be all about exponent rules and scientific notation. And on the back side, we've got some function information to focus on. So let's start with the exponent rules. Here you get to see all of the answers. I am absolutely not going to work out all of these, but I will work out some of the basics. For instance, here you've got the basic rule for multiplying powers together. If you expand it out, you can literally count how many x's are being repeatedly multiplied together there. If you expand this out, you could write 16 fives across the top, 14 fives across the bottom, and then cancel out every single one of the giant ones. Or you could visualize it and say, hey, I'm going to cancel out 14 of the 16 of those, and that's going to leave me with 2, right? So 16 minus 4 is 2. That seems a lot easier to just visualize it and do the subtraction. Here you've got the power of a power, so if you can't remember that when you're raising a power to a power, you multiply the exponents, then literally expand it out. 5 to the third times 5 to the third times 5 to the third is going to give you a total of 9 5s repeatedly being multiplied together. When you are dealing with the power of a product, this exponent, now you're going to use this exponent rule here every single time, and you just have to pay attention to the fact that we know that this is 4 to the first power, that's x squared, that's y to the third. So you're going to take and forward, and then the 1 times 4 power is fourth. X to the 2 times fourth power is 8, and y to the 3 times fourth power is going to be a 12. Or you can always expand it out. 4 times x times x times y times y times y. Write that out repeatedly 4 times. Count up all your 4s, count up all your x's, count up all your y's, and you will get to the correct answer. These guys in here tend to be the trickiest, and you really, you just got to separate them into their individual parts. So you're going to have your x to the 6th over x to the negative 2nd. You're going to have your y squared over y to the 3rd, and then you're going to have your z to the 3rd over z to the negative 1st. So do the same thing that we did here. Just take each one of these individual problems and solve them. So we're dividing, so we're going to take 6 minus a negative 2 becomes 6 plus 2. That becomes x to the 8th. This is going to be 2 minus 3, so it's going to be y to the negative 1st, and z is to the 3rd divided by z to the negative 1st. You're going to take 3 minus a negative 1 becomes 3 plus 1 is z to the 4th. So you could write it this way, or some of you may have actually chosen to do it a slightly different way. Oops, hold on for a second. Write this a little bit bigger. You could write this as x to the 8th, z to the 4th in the numerator, and then move this guy across the street so it doesn't have a negative exponent. Change it to a positive one across the street, and that would also be an acceptable way of writing this. They mean the exact same thing. Okay, so that covers the basics of all of these. If you have any others, oh, maybe I should do this one. Remember, whenever you've got a number that's raised to a negative exponent, take whatever your base is and write it as its reciprocal, then change your exponent to a positive. So this becomes 1/4 times 1/4, which is 1 over 4 to the 2nd, or 1 over 16, whichever one you'd prefer to write. All right, scientific notation. Being able to go from scientific notation to standard form, and then from standard to scientific notation. Remember, this tells you the number of places you're going to move the decimal. It's starting here, you got to move it 11 places to the right, which means you're going to have to add enough zeros to get there. So you've already got 2 decimal places, so once you move 2, now you only have 9 more to go, so add 9 zeros, and that's your answer. Here, you got to move it 9 places to the right, 3 places. This is a decimal number, so you're going to move it 7 places to the left. Add enough zeros to make that work. And then same thing here. Okay, so I'm now telling you about shortcuts. You should understand the basics of how this works, and you're ready for the shortcut. If it's to a positive power, it's going to be more than 1, so you move your decimal to the right. If it's to a negative power, It's going to be less than 1, so you move your decimal to the left this number of places. And now, for all of these, you identify what place is the leading digit in. This is the 100 billions place, which has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 zeros. So it's going to be 3.91 times 10 to the 11th. This is the 100,000th place. It's the 5th decimal place, so it's going to be 8.4 times 10 to the negative 5th. This digit, what is that, 123,000, so that's 10 to the 5th for 100,000. This is the 7th decimal place, so 5.02 times 10 to the negative 2nd, and so on and so forth. Okay, so once again, if you need me to work out any of those, let me know. Otherwise, I'm going to assume that you understand the basics of this and you're ready to move on to the test. Now, for functions, remember, when you've got functions, every input has to have exactly one output. It always has to be the same output. So when you're looking at these sets of numbers, we're looking for evidence where you plugged in a value for X and you got a different value for Y. Okay, so think back to the soda machine example that we had in our lessons from 8.3.1. If you press this button, you expect to get a certain flavor of soda. You expect it a Coke, right? So when you go back and you push the Coke button again, if a Sprite comes out, something is wrong. It's not working. It's not functioning properly. So this is the only one that's an example of one that's not a function. And then you look at this one and you say, well, how can this work? You plugged in a 4 and you got a negative 4. Then you plugged in a negative 4. Oh, wait, no, that would be okay. Because once again, you're plugging in one number and you're getting something out. But where's an example? Here's an example of one where it looks like it may not be a function. Because you plugged in a 0 here and you got a 2. And then you plugged in a negative 1 and you got a 2. And you're like, well, how can different inputs give you the same output? And actually, that's fine. This is like, your 2s might be your Diet Cokes. And you can have Diet Cokes that are so popular in your soda machine that you dedicated 3 different buttons to giving you Diet Coke. You press this button, you get a Diet Coke. This button gets you Diet Coke. This one gets you Diet Coke. That is totally fine. You don't have any situations where you hit a 0 and you got anything other than 2. There's no evidence of hitting a negative 2 and getting anything other than 2. So this is a function. Every one of these inputs has its own unique output. Now, why is this not a function? Because of those 2 points right there. 0 gave you a 1 this time, so when you get 0, you push the 0 button again, you expect to get a 1 again, but you got a 2. So that's not working properly. So this is an example of a situation that is not a function. And this is a function, right? I mean, it's kind of hard to tell, I have to admit. It looks like it might be going up straight there, but technically these are like little micrometers that it's moving away from the from that line, from the y-axis. So this is an example of a situation that is a function. Every value for x has only one value for y. Even that one right there. And that concludes our study guide. So let's move on to the chapter test. Good luck.
Hey, feeling good, like I should. When in dark, I walk around the neighborhood. Feeling blessed,